Hello everyone, so welcome back to my channel. Today we will discuss some MCQs related to topic SSP, that is solid state physics. Okay, so I have already written the questions. Now we will solve these questions. Okay, so the first question is the potential of a diatomic molecule, and these questions will be helpful for all those who are preparing for JAM, NET examination, CSIR NET examination, JEST, GATE, MSc entrance examination, and so on. Okay. So first question is the potential of a diatomic molecule as a function of the distance between the atom is given by r, that is equals to a by r square plus b by r to the power 10. The equilibrium distance between the atoms. So they have asked you what is the equilibrium distance between the atoms. So potential of a diatomic molecule, which is as a function of the distance between the atoms, is given by, this is basically a function. This is not r, this is the potential which is function of r, that is equals to a by r square plus b by r to the power 10. And now they have asked you what is the equilibrium distance. Now at the equilibrium point we can say that dV/dr, that is the change of potential with respect to r, that must be equals to 0. There is a concept of stable equilibrium, equilibrium, unstable equilibrium, and this concept I have explained thoroughly in previous lectures. So the description of that lecture I am giving in the description box. Please go and watch that video. I have explained it with the help of curves. Okay, so I think there you will get to know that why we do dV/dr equals to 0. Okay. So here we will use this concept that at equilibrium distance the change of potential with respect to distance will be equals to 0. Okay. Now if they have said you that after finding this, find the maximum value of potential or minimum value of potential, then we need to do the second derivative of potential with respect to r. Okay. But here they have only asked the equilibrium distance. So we will do dV/dr, that is equals to 0. This was the concept which we need to use here. Okay. This type of question you can also find in classical mechanics. So equilibrium distance between the atom dV/dr. Now a by r square, that is d/dr of this whole quantity, plus b by r to the power 10, that is equals to 0. So now this r to the power 2, that is r to the power minus 2. So we write minus 2a r cube minus 10b r to the power 11, that is equals to 0. So if we take the minus sign common, we will get 2a. Okay, in the question let me check once. A r square, here there is a minus sign over here. Here there is a minus sign. So there is a minus, so this one will be plus. Space is less here, so okay, let me write here and let me do the calculation here. So now this is minus 2a by r cube, that is equals to minus 10b r to the power 11. So we will get r to the power 8, that is equals to 10b by 2a, that is 5b by a. So we will get r is equals to 5b by a whole to the power 1 by 8, right? So our answer is option A is matching, that is 5b by a. These are all 1 by 8, okay? Not minus 8, these are all 1 by 8. So our answer is option A, okay? I hope you understood this. Now next question, which one of the following diffraction peaks will be absent in a powder diffraction pattern for BCC crystalline powders such as Fe? Okay, about this I have also taken a lecture of SSP. I think I have discussed over there. If not, I am repeating here once again. BCC means body crystalline structure. There are three main, basically we read about SC, BCC, we read about SC, BCC and FCC. Face centered cubic, body centered cubic, simple cubic. So what is the essential criteria for it? To show the diffraction peaks. Now for SC, all is valid like 0, 0, 0, 0, 1, 0, 0, 0, 1, like all. For BCC and FCC, there are some essential criteria. For BCC, the value of H plus K plus L, this needs to be even. And for FCC, H, K and L, this values needs to be even. This one, sum must be even, and for FCC, H, K and L, individually this must be even. Okay. Now we know, you know this, I think from option we will check 1, 1, 0. These are basically my H, K and L values. Okay. Now here they have asked for BCC. So we will check option A. What we are getting? 1 plus 1 plus 0. We are getting it 2. Option B, 2, 1, 1. We are getting 2 plus 1 plus 1, that is equals to 4. That is even. Option C, 2, 0, 0. That is 2 plus 0 plus 0. That is 2. That is even. And option D, 2, 1, 2. That is 2 plus 1 plus 2. That is 5. That is odd. And rest all these 3 are even. So these 3 are allowed. But in the question they have asked which one of the following diffraction pattern is absent, that is which one is not allowed. So clearly we can say that option D, which is an odd, which we are getting after addition of H plus K plus L. So this option D is not allowed. Okay, basic thing or basic trick which you need to know is that H plus K plus L, this value must be even for BCC, and H, K, L individually these three values must be even for FCC. Okay. And if you want, now there will be a question in your mind, why? Right? Yes. This concept which we can explain with the help of geometric factor. Okay. I think I have explained in some of my videos. If not, in the next video I will take a class of it, and there in details we will do the calculation, and from there we can understand why these values must be even for BCC and why for FCC individual values must be even. Okay. And intensity also depends upon this factor, that is geometric factor, square of geometric factor. Okay, in detail we will study, but here this is the trick which you need to know. Now question number 3. The critical field for lead are 1.2 into 10 to the power 5 ampere per meter and 3.6 into 10 to the power 5 ampere per meter at 12 Kelvin and 10 Kelvin respectively, and its critical temperature at 0 Kelvin is okay, you have to find the critical temperature at 0 Kelvin. Fine. So there is a formula for it which you need to know. What is the mathematical formula which here it will be useful is that H, that is the critical field at any temperature T, is given by H at 0 Kelvin 1 minus T by Tc, that is the critical temperature whole square. So this is the formula which you need to know here. Okay. So now bus we have to put the values and we will get the value of the critical temperature at 0 Kelvin. That is, we will get the value of Tc. Okay. So now substituting these values, we will get two equations. First equation, the value is 1 point value of H, that is the critical field at temperature T when my T is 12 Kelvin. So 1 minus 12 by Tc square. This is my equation 1. And my equation 2 is 3.6 into 10 to the power 5. That is H critical field at 0 Kelvin 10 square by Tc square. This is my equation number 2. Now we will divide this both equation. Dividing equation 1 with equation 2. This is with, okay, with or by equation 2, we get 1.2. Oh, space is less. So 1.2 by 3.6. Critical field at 0 Kelvin will be cancelled. So we will get here 1 minus 144 by Tc square by 1 minus 100 by Tc square. So this is, here we will get 1 by 3. So we will get 1 by 3, that is equals to Tc square minus 144 by Tc square minus 100. So Tc square minus 100, that is equals to 3 Tc square minus 3 into 144. So 3 Tc square, this will come here, so 2 Tc square, that is equals to 3 into 144 minus 100. So 3 into 144 minus 100, we will get 332. So Tc is equals to root of 332 divided by 2, that is 166. So let me first see the answers. Okay, so 166 is see 12 square is 144. So obviously, and 13 square is 169. So obviously this one will be in between 12 and 13. So our right answer is 12.88K. In this way you have to get your answer. Okay. Now question number 4. Target of an X-ray tube is subjected to an excitation voltage V. Wavelength of the emitted X-ray is proportional to. Okay, the options are 1 by V, root V, 1 by V and V. Okay, so first we need to find, here they have said to find the wavelength. Okay, we will use our de Broglie's hypothesis. We know what lambda is equals to what, H by P, right? Using de Broglie wavelength, we know de Broglie wavelength lambda is equals to H by P, where H is what, the Planck's constant, and P is what, momentum. Again we know P is equals to what, root 2m E, where E is the energy. Okay, so we will substitute these values. Now here they have said excitation voltage V. So at equilibrium we can say what, E is equals to, energy is equals to EV, correct? The E is what, kinetic energy, which is must be equals to EV. Excitation voltage is V. So instead of E we will substitute 2m EV. So clearly we can see from here that lambda is proportional to 1 by root V. Okay. This type of question also you can expect in SET examination also. GATE, SET, MSc entrance exam. Okay. So our option A is correct. Option A is correct. So today we will stop here. Today we have done 4 questions regarding SSP. So in the comment box you can tell me that you want MCQs of which particular topic. Then in the next video I will bring that topic. Okay, and I said you that I will give you one theory lecture regarding that why my values of BCC and FCC, that allowed values of H, K and L, to explain that concept. Okay, so that one also I am going to bring that soon. Okay, so keep studying and thank you so much. And in my upcoming videos now I will only bring this type of MCQs, and some theory I will discuss in the MCQ lectures only. Okay, so thank you so much, keep studying.